Hello class. In this short video today we'll be talking about ions and ionic compounds. You guys know that ions are atoms that have charge. Okay, now where does that charge come from? It comes from loss or gain of electrons. Now, so when atoms gain or lose electrons, they become ions. Okay, positive ions which result from a loss of electrons are called cations, and a gain of electrons, which results in a negative charge, those ions are called anions. Okay, why do atoms gain or lose electrons? This has to do with their quest for stability. Okay, sometimes when an atom gains or loses electrons, it becomes more stable. It acquires a full octet. Okay, so that's the driving force behind the gain or loss of electrons. Okay, so here you can see that the cations, most cations, are toward the middle and the left of the periodic table, and the anions, which are the negatively charged ones, are located toward the right side of the periodic table, because those are closer to the noble gases. So I mean, the ones that are to the right are closer to the noble gases, so they are happy to gain extra electrons to have the same electron configuration as the closest noble gas. Okay, so non-metals tend to become anions, and metals tend to become cations. Okay, so this is a good rule of thumb to know. These are just as you guys can see on this chart, the red dots are ions that are known, that exist, that are stable, and the white dots are ones that are not very stable. So you can see, for instance, if we look on the x-axis, if you look at 25 is Mn, manganese. So manganese can have, I don't see my, here. Manganese can have a charge of +2, +3, +4, +5, +6, +7. All of these are possible for manganese. On the other hand, as you can see here, zinc, number 30, can have only 2, that are the +2. That's the only stable zinc that we know. Okay, at the other hand, the silver makes only a +1, that is stable. There is a +2, but that's not very stable. Okay, not very common. Now let's take an example, NaCl, which is a quintessential example of an ionic substance. It is made of Na, which is a metal, and Cl, chlorine, which is a non-metal. So generally, ionic substances are made of metals and non-metals. Here you can see that the metal, which is the sodium, originally had 11 electrons, but it lost. It will be happy to lose one of them, and now remain. I mean, only 10 will be left, since we have 11 protons. So we have 1 proton more than the number of electrons, so the charge is going to be a +1. And chlorine, on the other hand, which had originally 17 protons and 17 electrons, and since it is close to the noble gases, is happy to gain an extra electron. Now, where does that extra electron come from? Guess what? It comes from the sodium. Here it is. So chlorine is happy to gain that extra electron, and now it has 18 electrons versus 17 protons, so it has 1 extra electron compared to the number of protons, so it is going to be negatively charged. Now, the protons and the anions and the cations form a 3-dimensional network called a crystal. Okay, so NaCl is not an empirical formula or a molecular formula. It is a formula unit. Okay, there is no such thing as Na bonded to Cl by themselves, forming one entity. That doesn't exist. So Na and Cl are bonded, exist in a 3-dimensional network of billions upon billions of Na plus and Cl minus ions bonded to each other. Now, it's easy, very easy to write the formula of ionic substances if you can determine the charges. You can determine the charges by looking at the periodic table, but let me say this right away. You can do this only for representative elements. And representative elements are the first 2 families and the last 6 families. So for those 8 families total, we can look at the periodic table and pretty much guess what the charge should be, especially for those elements that are toward the upper side of the periodic table. Since the way we do it, and you know, the technique behind it, or the logic behind it, is because matter is neutral, so the total number of negative charges should be equal to the total number of positive charges. For instance, in this particular case, we have Mg2 plus and N3 minus. Now, if we wanted to get the actual formula for this, since we have 2 positive charges and 3 negative charges, we should look at the least common multiple, which is 6 for both, which means that we will need 3 magnesium atoms, or ions, sorry, and 2 nitrogen ions, okay, nitride ions, if I may say. So this results in the formula Mg3N2. Another easy way to do it is what we call the crisscross rule. So you take the -3 from nitrogen and use that 3 as a subscript for Mg, and you use the number 2 on the 2 plus of magnesium and use that as a subscript to nitrogen. So Mg3N2. Okay, so that's what we just explained, and this is the crisscross rule. Once we have used that crisscross rule, we should still simplify if it is simplifiable, and we will explain that in class. If you don't understand it, please ask in class and I will explain. All right, learning check. Let's see if you could handle these first 5 examples. The rest of them we will do in class. There you have it. These are the ones you'll be doing in class, so you should try the first 5. And if you want to do all of them, that's fine, but we will be doing them in class. Okay, so this was the short video about ions. Again, rewind, ask questions. Write down questions, sorry, and then ask them in class. Thank you, and see you in class. Goodbye.